Alright, welcome. In this video, we're going to have a brief discussion of graphs of arc trig functions and actually computing inverses of trigonometric functions. So we're going to start with y equals arc sine x. So like I told you in the last one, that's the inverse function for sine x. But I'm going to kind of go through the same process of finding an inverse, like I reminded you about last time. I'm going to start with the idea of f of x equals sine x. And then we're going to think about the domain and range of the original. Okay, remember what we said last time was in order to construct an inverse function for sine x, we have to restrict its domain to be negative pi over 2 to pi over 2. And then the range of sine or cosine, it's going to be negative 1 to 1, if we haven't changed the amplitude or the midline. Okay, now remember that f of x equals y equals f of x, and x equals f inverse of y. So we're going to say y equals sine x, and we're going to start solving for x. We want to get rid of the sign, but we can't divide by sign because sign isn't a number, it's an operator. So we do the inverse operation of both sides. We take inverse sine of y, and we get x. Okay, and now remember, x is f inverse of y once we've solved for x. And then, okay, I've got an expression for f inverse, right? F inverse of something is inverse sine of that thing. And we're oftentimes interested in finding f inverse of x, and that's what we're doing if we're graphing y equals arc sine x, is we're graphing the inverse function, thinking about x as the input. And so we've got that there. And if I think about the domain and range of the inverse, okay, remember we just switched the domain and range of the original. Okay, so the domain of the inverse will be the range of the original, negative 1 to 1, and the range of the inverse will be the domain of the original, which is negative pi over 2 to pi over 2. Alright, now, I'm going to be taking the easy way out. If I'm being honest, I think that the best way to show you about the graph of these is to show you using technology. So I'm going to graph y equals inverse sine x and think about, what we just wrote down, that the domain of the inverse function was going to be negative 1 to 1, and the range was going to be negative pi over 2 to pi over 2. And that's exactly what we're seeing here. Okay, and so I would grab this graph, back to my notes, and just paste it right in there. And I'm realizing maybe blue was probably not the right choice of color. There we go. Okay, and that's the graph of arcsine x. And I'd say what's important about it, obviously the domain and range, but the other thing I could point out is this point right here where we're going through the origin. I think I would point out that inverse sine of 0 is equal to 0 radians. That's the most obvious place on the unit circle where sine of theta equals 0. And, and the reason for that is because sine of theta, because sine of 0 radians is 0, it's going to go through the origin, right? It's inverse sine of 0 is also going to equal 0. The graph of arcsine passes through the origin. For arc cosine, I'm going to do the same thing, but maybe a little bit faster. So I'm going to think about f of x equals cosine x. We're trying to graph the inverse function for this function. So y equals f of x, and, well, I guess before that I need to think about the domain. Yeah. Domain, that we're going to restrict the domain of cosine to 0 to pi so that we can construct a suitable inverse function that will be a function in its own right. Y equals cosine x because y equals f of x. If y equals cosine x, then x is going to be inverse cosine of y. And that x equals f inverse of y, so I've got f inverse of y equaling inverse cosine of y, but I could just, plug in x is there, and then think about switching the domain and range of the original function to get the domain and range of the inverse function. Okay, so the domain and range of inverse cosine are going to be negative 1 and 1, negative 1, 2, 1, and 0 to pi. But that range being 0 to pi, to me, that means I'm going to be expecting to see all of the graph above the x-axis, all positive, y values on the graph of y equals arc cosine x. Okay, so if I go to graph this thing using technology, and I, call for y equals inverse cosine x, I'm going to see that graph there. Okay, and so like we thought, the whole graph was above the x-axis, all positive y values. And the point I would emphasize, on this graph is right there. And what's happening here is, inverse cosine of 0, right? We're graphing arc cosine of x, and we're plugging in 0. So in arc cosine of 0, okay, we're thinking to ourselves, where on the unit circle is cosine of theta most obviously equal to 0? And that's going to be up at pi over 2. Theta equals pi over 2. And so that's, that point there. But I think I got something even better for you. Okay, so I think the best way to remember which graph is which, suppose you had to pick them out of a photo lineup in a multiple choice setting, would just be to think about the, underlying circle situation that we talked about in the last video, where if we're trying to find inverse sine values, we're looking on the right half of the circle. But if you look at the yellow spots on the circle, we've got places above and below the x-axis. And, this is kind of a coincidence, but also kind of not. And then if you look at for arc cosine, the circle that we draw that I'm only choosing the top half, all of that is above the x-axis. So I think that's, me personally, these graphs are not important to me. They're not important in AP Calculus. We're not going to use them a whole bunch in this class even. And so if I'm just trying to remember which one's which, now I'm remembering that, I know this about inverse trig, this is where we're looking, and that can also help me remember which graph is which. Now, for arctangent, I'm going to do the same thing again, but this time I think I need to remind you about what the graph of y equals tangent x looks like, because that's, materially different from the graphs of sine x and cosine x. Okay, so, just reminding you, tangent x is the graph that has the arms and the vertical asymptotes. Okay, and this is the picture of the graph of f. So if I think about domain and range, okay, really I'm interested in restricting the domain of this function to negative pi over 2 to pi over 2 so that there's a suitable inverse, right? And so that'll be, getting rid of that. Okay, and so this will be, giving us the full picture of tangent, all of the outcomes that are possible because it's going up to infinity and down to negative infinity. So since we're seeing that, we're going to say that the range is all real numbers. You saw what I did with the last two. F inverse of x is going to be inverse tangent of x, and we can switch the domain and range, and that'll kind of give us an idea of what the picture of the graph of inverse tangent is going to look like. Okay, the domain is all real numbers, and we saw that in the last video when we were able to take arctangent of 999. Right? Okay, we can put anything we want into arctangent because tangent achieves all real numbers at some place between negative pi over 2 and pi over 2. And then the range is the open interval negative pi over 2 to pi over 2. And the only way that we can have an open interval as our range is if we have some sort of a horizontal asymptote. Okay, so if we go to technology and request a graph of y equals arctangent x, this is what we're going to see. All right, and we're seeing those horizontal asymptotes. And, I think I've got a little bit more to say about these horizontal asymptotes, but, I'm just going to kind of clip this, bring it into the notes, and kind of draw on that. Now, the first thing I would notice when I, put the graph of arctangent x next to the graph of regular tangent x is that, okay, the vertical asymptotes on the graph of y equals tangent x have become horizontal asymptotes on the graph of y equals arctangent x. And that makes sense, thinking about the domain and range being switched and everything. But I would also point out, that we could think about this kind of the same way we did in the last video when we think about inverse function values. And I even mentioned this then, that as theta approaches pi over 2 from below, tangent is going towards positive infinity. Well, we could write that using a limit, because this is AP Precal and we need to be, up with our limits. So I'm going to say the limit as theta approaches pi over 2 from below of tangent theta, that's going to equal positive infinity. And we're kind of seeing more evidence of that, or maybe a shadow of that, in the graph of y equals inverse tangent x, over here where we've got a horizontal asymptote. And remember, horizontal asymptotes are limits as x approaches infinity. So we're saying the limit as x approaches infinity of inverse tangent x equals pi over 2. The most obvious place on the unit circle where tangent theta is approaching infinity is going to be, well, as theta approaches pi over 2. Okay, so I think that's what I've got to say about the graph of these three functions. But before I let you go, I want to do a couple more examples about finding inverse functions, just algebraically. Okay, so there's a couple of them. Here, the first one is f is given by f is 1/3 sine x, for x being between negative pi over 2 and pi over 2. Find f inverse and give the domain and range of that inverse. All right, so I'm just going to start by saying, all right, that's the domain right there. They gave it to me. And then the range, hey, I need to remind you that sine x for every x is somewhere between negative 1 and 1. And it could equal negative 1 or 1 at the extremes of the circle. And I've got 1/3 sine x, so I'm just going to multiply all three sides of this inequality by 1/3, and I would see that, 1/3 sine x is between negative 1/3 and positive 1/3, and that's going to give me my range. Okay. Now, I'm going to say, all right, well, f of x, that's equal to y. And so y equals 1/3 sine x, and I'm going to start solving for x. So I multiply both sides by 3, and I want to get rid of the sign, but I'm not going to divide by sign. I'm going to take inverse sine of both sides, and I get x equals inverse sine of 3y. I'm going to say, all right, x equals f inverse of y. That's inverse sine of 3y. And so I've got a formula for f inverse. F inverse of something is inverse sine of that thing, and I could plug in x if I liked. Okay, and then thinking about the domain and range of this inverse, that's just going to be the swapped domain and range from the original. So the domain of the inverse will be negative 1/3 to 1/3, and the range will be negative pi over 2 to pi over 2. And with this other one, I'm just going to do the same thing. Okay, they're telling me h of x is equal to 4 cosine of 2 pi x, and they're giving me the domain. Okay, so I'm just going to label that as the domain. Now I need to find the range if I want to find h inverse and give its domain and range. So the range, it's going to just start with the idea of cosine. Now, if you think of this, you see that midline 0 and the amplitude's 4, and you know it's going to be negative 4 to 4, great, go for it. But if you're not seeing it, it's because cosine of a thing, anything, cosine of theta, any angle, is between negative 1 and 1. So if I multiplied that by 4, and maybe in this case theta equals 2 pi x, I'd be stuck between negative 4 and 4, and so that's going to be my range. Okay? Say h of x equals y. So y equals 4 cosine of 2 pi x. And then I'm going to start solving for x. I'll divide both sides by 4, take inverse cosine of both sides, divide both sides by 2 pi, and I'd have x equals. All right, I've solved for x, and that means I've got h inverse. So h inverse of y is equal to 1 over 2 pi times inverse cosine of 1/4 y. And so I've got h inverse as function, proper function, and I'm going to, plug in x to it and think about the domain and range of the inverse. The domain of h inverse will be the range of h, which is negative 4 to 4. And the range of h inverse will be the domain of the original h, which would be 0 to 0.5. And that's it. That's all I got for you. That was kind of a lot of discussion, especially in conjunction with the last video about inverse function values. But these don't really comprise all that much of the AP exam. It can't show up in free response, and we know it's not going to be a major component of multiple choice. So, it's important because it's one of the things that we have to learn about, but it's not going to be like the most important stuff. Okay, so that's all for this video. Thanks for watching.